Hey, what's up everyone? Welcome to Layman's Concept channel. Today we're going to talk about an interview question commonly asked in data science interviews, which is how to handle class imbalance data. We will discuss about 7 techniques that can help you to train a classifier to detect the abnormal classes. The first thing, use the right evaluation metrics. Imagine our training dataset has 99.8% zero cases and 0.2% one cases. If accuracy is used to measure the goodness of a model which classifies all testing samples into zero will have an excellent accuracy, let's say 99.8%. But obviously, this model won't provide any valuable information for us. In this case, other alternative evaluation metric can be applied such as precision, recall, FN score, even AUC. The second technique is resampling the training data. Apart from using different evaluation criteria, one can also work on getting different dataset. Two frequently used approaches to make a balanced dataset out of an imbalanced data are undersampling and oversampling. In undersampling, the undersampling method balances the dataset by reducing the size of abundant class. This method is used when quantity of a dataset is sufficient, by keeping all the samples in rare class and randomly selecting an equal number of samples in abundant class. Whereas oversampling is used when the quantity of data is insufficient. It tries to balance dataset by increasing the size of rare samples. Rather than getting rid of abundant samples, new rare samples are generated by using example repetition, bootstrapping, or smooth. The third method we can use is use careful cross validation in right way. Cross validation should be applied properly while using oversampling method to address imbalance problems. If cross validation is applied after oversampling, basically what we are doing is overfitting our model to a specific artificial bootstrapping result. That is why cross validation should always be done before oversampling the data. Only by resampling the data repeatedly, randomness can be introduced into the dataset to make sure there won't be an overfitting problem. So the fourth technique that we can use is ensembling different sample datasets. The easiest way to successfully generalize a model is by using more data, right? So the problem is that out of the box classifiers like logistic regression or random forest tend to generalize by discarding the rare class. One easy best practice is building n models that use all the samples of the rare class and n differing samples of the abundant class. Given that you want to ensample 10 models, you would keep example 1000 cases of rare class and randomly sample 10,000 cases of abundant class. Then you just split the 10,000 cases into 10 chunks and trained in 10 different models. This approach is simple and perfectly horizontally scalable if you have a lot of data. Ensemble models also tend to generalize better, which makes this approach easy to handle. The fifth method that we are going to talk about is resample with different ratios. The previous approach can be fine-tuned by playing with ratio between the rare and abundant class. The best ratio heavily depends on the data and the models that are used. But instead of training all models with the same ratio in the ensample, it is worth trying to re-ensample different ratios. So if 10 models are trained, it might make sense to have a model that has ratio of 1:1, like rare is to abundant, and another one with 1:3 or even 2:1. Depending on the model used, this can influence the weight that one class gets. So sixth method that we're going to talk about is cluster the abundant class. Instead of relying on random samples to cover the variety of training samples, clustering the abundant class in R groups, I'm saying R is n number of groups, with R being the number of classes in R, for each group, only the midpoint, which is center of cluster, is kept. The model is then trained with the rare class and the midpoints only, which help us to solve this class imbalance problem. And finally, the last method is design your own models. All the previous methods focus on the data and keep the models as fixed component, but in fact, there is no need to resample the data if the model is suited for imbalanced data. The famous XGBoost is already a good starting point if the classes are not skewed too much, because it internally takes care that bags it trains on are not imbalanced, but then again, the dataset is resampled, it is just happening secretly. By designing a cost function that is penalizing wrong classification of the rare class more than wrong classification of abundant class, it is possible to design many models that naturally generalize in favor of rare class. For example, tweaking an SVM to penalize wrong classification of the rare class by the same ratio that this class is underrepresented. Finally, this is not an exclusive list of all the techniques, but rather a starting point to handle imbalanced data. So there is no best approach or model suited for all the problems, and it is strongly recommended to try different techniques and models to evaluate what works best. Try to be creative and combine different approaches. It's also important to be aware that in many domains, for example, fraud detection, real-time bidding, where imbalance classes occur, the market rules are constantly changing. So check if past data might have become obsolete.